Hello, so this is just a visualization that I built of a Bloom filter. A Bloom filter is an alternative to a hash map where it kind of replaces the function of if you have to check if something is in a set, a Bloom filter is a lot more effective. If you are okay with having the occasional false positive, the big problem with hash maps is you have huge memory usage, and Bloom filters do not have such a problem. So this is just a bit of a visualization I built. As you can see, you can have up to 10,000 bits. This depends on how many things you were expecting to store. But for the sake of example, we can just do 1,000 because it's a nice number. You can also manipulate the number of hash functions you have. This is again important in the math. As you have more and more inputs, it's a good thing to have more hash functions as this lessens the chance that you will have collisions. But for just example, we'll use 3. Now we can just put a word into the set, insert cat, so cat will correspond to 3 different bits being flipped up. Dog will correspond to these bits being flipped. Table will respond to these bits, and each of the 3-bit flips correspond to the number of hash functions. If we had 4 hash functions, we'd flip 4 bits, and so on. So this is how we introduce words into our set. Now let's say we have table, and we want to check if it's in the set. The program we're going to do is going to run table through the 3 hash functions and then check that with the bits that table flipped. Check. Table might be in the set. The reason we use might is because there is the possibility that other words mapped those 3 bits to up, which would give a false positive. But as you can see here, the false positive rating is there. I can put in a number of random words just to show as we input more words, the chance that we'll have a false positive increases. Um, so yeah, so this is just a visualization of the Bloom filter. It's pretty cool, and thank you. Also, it looks like GitHub, because don't we all love GitHub so much? Okay, thank you.